This is another example of solving a system of linear inequalities by graphing. So here are our two inequalities, and we want to solve them by graphing. So what I would do, notice, is that each of these equations is in standard form. So the easiest way to find points that lie on those lines, we call them boundary lines in a system of inequalities, is to find the intercepts. So to find the y-intercept, I know to substitute 0 in for x, and when I do that, I'll have 2 times 0, which is 0, minus y equals 4, equals if it's on the boundary line. So minus y equals 4, that means y has to be negative 4, because minus negative 4 is equal to 4. To find the x-intercept, I'll sub 0 in for y. And I'll have 2x minus 0 is equal to 4, which means x would have to be 2, because 2 times 2 is 4. When I plot those points, I'll have a point at 0, negative 4, and a point at 2, 0. And I'd like to use a straight edge, but on my iPad here I cannot. So I'll do my best to make this line straight through those points. Now this line needs to be solid. And the reason it needs to be solid is because this inequality has an equal sign with it. That means it does include points that lie on that boundary line. Whereas this inequality for the second condition in my system does not have an equal sign with it, and therefore that boundary line will be dotted. I'm going to go about finding points on that line in the same way. I'm going to find the y-intercept by substituting 0 in for x. Y would have to be 1 because 2 times 1 is 2. Find the x-intercept by subbing 0 in for y. Y would have to be 2. So my second line here goes through 0, 1, and 2, 0. Well, right away, I see that these lines have the same x-intercept. But there's more to this than that, because each of these has a less than sign in them. So what I need to consider is which side of the line should I shade on. So for the first line, if I substitute 0, 0 in for x and y, I'll have 2 times 0 is 0, minus 0 is 0. So now I ask, does that come out to be a true sentence? Is in fact 0 less than or equal to 4? It is. And therefore I know that for this first line, I'm going to need to shade on the side of 0, 0. And so I'm going to do that in one color here. I'm shading on the side of 0, 0 for that first line. Well, now I'm going to do the same thing for my second line. Using the easiest pair of coordinates, 0, 0, I would get 0 plus 2 times 0 is less than 2, and 0 is less than 2. So for my second line, I also need to shade on the side that contains 0, 0. So that would be below it here. Well, now I want you to notice that there is one triangular region that is shaded in both red and in blue. And it's this region right in here. So this region contains points that are the solution set to this inequality, or system of inequality, excuse me. This green region, any point in it will satisfy both conditions in my system. Let's demonstrate. If I pick a point other than 0, 0, which of course we know worked in both of those inequalities, say I pick this point right here at negative 1, 0. If I substitute negative 1, 0 into the first inequality, I'll have 2 times negative 1 minus 0 is less than or equal to 4. Well, 2 times negative 1 is 0, and 0 minus 0 is 0. Yes, in fact, 0 is less than or equal to 4. If I substitute negative 1, 0 into my second inequality, I'll have negative 1 plus 2 times 0 is less than 2. Well, negative 1 plus 0 is negative 1, and that is less than 2. So I know I've got the correct region shaded. Now I just remembered I made a little mistake. In my second system, that line should have been dotted because, again, there was not an equal sign with that inequality. So this second line, boundary line, should have been a dotted line, not a solid line.